Okay, in lesson 1 of mod 2, we're going to multiply multi-digit whole numbers and multiples of 10 using place value patterns and the distributive and associative properties. Now up to this point we've only multiplied single digit numbers, not multi-digit numbers by powers of 10. Okay, question 1. My pointer, there it is. It asks us to fill in the blanks using knowledge of place value units and basic facts. Okay, over here we have ones and tens. Okay, so it says 23 times 20. We've rewritten in the standard forms 23 ones times 2 tens. But as you can tell, if I had 1 1 times 1 10, I would end up with 10. Okay, so 23 ones times 2 tens is going to give us 46 tens. And 46 tens would be written as 460. On B, this time, you notice we are multiplying tens times tens. So now we have 23 times 2, which we know is 46. Now if I had 10 times 10, that would equal 100. So instead of being tens times 10, instead of just being tens, this is actually hundreds. You see, if we wrote this as 46, the 6 would have to be in the hundreds place. 46 hundreds. And you notice this was tens times tens. In our previous lessons, we've always multiplied ones times tens or ones times hundreds. We'll do one more. We're going to do D. This time, if you notice, we've rewritten 410 as 41 tens, and 400 we've written it as 400s. When we multiply this out, we have 41 times 4. Well, 4 times 1 is 4. 4 times 4 is 16, so we have 164. But if you notice, we have tens times hundreds, which will give us thousands. So this is 164 thousands. So when I write this, so this means 410 times 400 is 164 thousands. Okay, the first question here, they're wanting us to verify if the equations are true or false. Defend your answer using knowledge of place value and the commutative, associative, and distributive properties. Now, we haven't talked much about the associative and distributive properties yet. Well, excuse me, associative and commutative properties, but we have talked about distributive property. So we'll get that further into class. But let's take what we already know and see if we can see if these are true or false. On this here, if we said 6 tens, well, I know 6 tens would equal 660. And 2 tens would equal 20. And 3 tens would equal 30. Now I can see right now that this here is actually going to be equal to 600. So this would be a false statement. And it's a false statement because 660 is 1/10 the value of 20 times 30. Now if we look at B, I can see this now. I can work out both sides, but what I'm going to do is I'm going to combine them. I'm going to go ahead and work out some of the problem, and then I'm just going to compare the two. So I know this being a multiplication problem on B, I can multiply them in any order I want. Doesn't matter. So I'm going to take 44 times 10. That gives me 440 times 20, which equals 440 times 2. Now, at this point, I do not need to go any further. I can see that this one and this one are not going to be of equal value. So this is a false statement. And the reason being is the first one is 10 times greater than the second expression. And I'll do one more. Well, actually, I think I'll leave it at that at this point. That gives you 3 good examples after that. Okay. Question 3 is asked to define the product. Show your thinking. The first row gives some ideas of how to show your thinking. Because basically this is showing 7 times 9 is 63. So we know 7 times 90 equals 63 times 10. And basically all they've done is 9 times 3. They decoded it. Because if you were to decode this, you would go 7 times 9 times 10. And that means 7 times 9 would be 63 times 10, gives us 630. Now here on the third one, we have 70 times 90, and they're distributing it to where 7 times 10 times 9 times 10. And since we really do not need these parentheses, we could take them out, because multiplication we can do it in any order we want. What they're doing is they're reshuffling it, and they're taking 7 times 9 times 100, because 10 times 10 makes it 100. And now we have a basic math fact of 63 times 100, which we know is 6,300. Now we have 70 times 900. They did the same thing here. They're breaking it down to 7 times 10 times 9 times 100, which allows us to turn around and say 9 times 7 times 10 times 100. We know 7 times 9 is 63, and 10 times 100 is 1,000. So 63 times 1,000 gives us 63,000. I'm going to come down to C, and this says 40 times 5. Well, I know 10 times 4 equals 40 times 5. That allows me to go 10 times 20, because I multiplied 4 and 5 my basic math facts. Now I have 10 times 20, which gives me 200. So all we're doing is really decomposing each one of these numbers so we can use basic math facts. On the second one, once again, I'm going to do 10 times 4 times 5 times 10. Now I can change them around now, so I can have 4 times 5 times 10 times 10, which gives me 20 times 100, which gives me 2,000. This one we're going to go 10 times 4 times 5 times 100. So when we change them around, we can go 4 times 5 times 10 times 100, which now we have 20 times 1,000, which gives us 20,000. And our last one is 4 times 100 times 5 times 1,000. We put them together, we know we got 4 times 5 times 100 times 1,000. So we end up with 20 times 100,000. So that's going to give us 2 million. I'm going to go to 5. A Canadian side of the Niagara Falls has a flow rate of 600,000 gallons per second. How many gallons of water flow over the falls in 1 minute? Now this is giving you a two-step problem. We can see this is per second, and here it's asking for an answer in a minute. So we're going to draw a tape diagram. And it says here the Canadian side, the Niagara Falls, has a flow rate of 600,000 gallons per second. How many gallons in 1 minute? So our total up here, this is going to be gallons in 1 minute. Now, here I'm going to draw one of them. And I know this is 600,000. And the way I draw this is I know there's 60 of them because there's 60 seconds in 1 minute. So now in order to solve this, I know I've got to take 600,000 times 60 to solve for our answer. Well, doing what we just did, we know this becomes 100,000 times 6 times 6 times 10. And I'm going to put parentheses to show you which ones I decoded for them. And what this allows us to do is, since it's multiplication, we can do it in any order. I'm going to do 6 times 6 times 100,000 times 10. This gives me 36 times 1 million, which 36 times 1 million is going to give me 36 million. So the answer is 36 million gallons of water flows over Niagara Falls each minute. That's a lot of water.